So in this tutorial, we're going to look at changes in the global energy balance through terrestrial albedo changes and feedback loops. I think it's well known that dark surfaces absorb heat and light surfaces reflect it. And this is reflected in the concept of albedo. Albedo represents the ability of a surface to reflect solar energy back into space. It's normally presented as a percentage. So in the diagram, we can see that fresh snow has an albedo of 80 to 95%, meaning that it reflects back into space 80 to 95% of incoming solar radiation. Asphalt, a darker surface, has an albedo of 5 to 10%, meaning it reflects only 5 to 10% of that incoming solar radiation. So very clear differences in albedo surface means different patterns of absorption of solar radiation, and therefore differences in atmospheric budget. Albedo is important because it can have a long-term impact on atmospheric temperature. Now, changes to albedo surface can be anthropogenic or natural. One example might be converting forest cover into pasture. So forest has an albedo of 10% to 20%, and by deforesting to grassland, albedo is increased to 25 to 30%, and so therefore lowering potential atmospheric temperatures. Changes in terrestrial albedo also occur naturally. So a natural warming of the temperature would lead to sea ice loss, which in turn would convert to darker ocean that absorbs more heat, which in turn would lead to increasing temperature and faster rates of sea ice loss. So we see here how one change can result in an acceleration of that change. And this is something we might call a positive feedback. So positive feedbacks increase the change or output. The result of a reaction is amplified to make it occur more quickly. So an example of increased cloud cover increases the reflection of infrared radiation by clouds and warms the climate, thus resulting in a positive feedback. Negative feedbacks reduce the change or output. The result of a reaction is reduced to bring the system back to a stable state. So the albedo of increased cloudiness cools the climate, resulting in a negative feedback. Now, in the context of the atmospheric budget, and in particular with albedo, most feedback loops here tend to be positive. And the diagram here shows you the main sources of planetary amplifying positive feedbacks in relation to carbon. When we think about carbon, I think it's important to examine the relationship first. I'd say the relationship is a causal relationship. In some cases, temperature increases can lead to an increase in carbon in the atmosphere, and sometimes carbon increase leads to temperature increases. And I think if you look closely at the pattern here, yes, there's a relationship, it's clear to see, but sometimes temperature change precedes carbon change, and then in other instances, carbon change precedes temperature change. So we see a causal relationship, but it's not one way or the other. Now it's really important, this relationship, and the interaction is very important to the global energy balance, as carbon fluxes between the biomass, oceans, and atmosphere interfere and modifies the greenhouse effect. So changes in storages of carbon occur due to long-term changes in atmospheric temperature, ocean temperature, and land use. And of course, anthropological factors need to be taken into account. So there are many different forms of feedback relating to the atmosphere and the carbon cycle. and I'm going to explore that in the next tutorial.